we have a bunch of blogs and webcasts and stuff, so it's not important to go into it now. But what we really do want to get into is the bit that I worked on for this, also written in Node, is called mlogin, which is an interactive job essentially. So you run mlogin, and it creates a job, just a regular piece of Node.js software, and then you get essentially a shell, just a regular Unix shell, through we used some HTTPS WebSocket stuff to do this. So there's a CLI that speaks WebSockets to a server, and you can, it's a regular Unix environment, and it's really good for when you prototyping jobs to run in the Manta system. It's really good to be able to do that interactively. If you essentially log directly into the Unix machine that you get access to. And here, so it is the quickest way to run software in an instance on the Joyent public cloud, and your only build per second that you use, and per second cost is like some tiny amount of fractional cents or something. So, and that when you up, one of the things that we use it for a lot in Joyent, which speaks to earlier, the stuff that I was talking about with the modular debugger and call files, is that we actually, when we have production problems with systems, we create call files, like either the system fails immediately and a call file is generated, or we take a call file like discretionarily before we start the service. We upload those into Manta, and then sometimes they can be huge. They can be like gigabyte. The Node heaps can be about a gig and a half. But we also have larger pieces of software like Postgres. Sometimes they're dump core, and we need to look at the core dumps of those. But in the case of Node, for instance, I run something. I created a core dump earlier. So I run mlogin on that core dump. This will log me into a Unix compute node in the cluster, and it will mount the core dump that I had previously uploaded. Like in this case, it's like 30 meg, but they can be pretty big. So rather than have to download it onto my machine or like copy it across the network to some other place, they just get dropped on a machine that has a copy of this data on it. Eventually, sometimes the internet's not great in this way. So once we're in though, I can see the file is mounted just regularly in the file system, and we can run MDB on it. So you don't have to like have MDB on your laptop or anything. You just like log in and run MDB, and then you can do a stack trace. And you can see that in this particular case, it was running some stuff that broke. There was an exception that was thrown. Throw. And then that aborted and caused a core dump, which we then saved into Manta, and then we can log in and look at it, add the ledger, because production is up again, so we restarted the service, which is always good. There is another particularly exciting command, which Brian has written a long blog post on, called find.js objects, which lists every object that we can find in the heap process. So you can go back and look through all of the things in the process. If you know that an object in your process has a particular property name, you can find all of the objects that have that property in them. Yeah, the list of all of them, and then print them out. So if you have some status object that has like, the number of requests that you've dealt with, so in this particular case, we have passed the initialization phase and we've done 14 things, and there was a core dump because of some bug in the code. You can imagine that you can store and track a bunch of status information in an object, like in the global scope potentially, and then go and find it in the core dump. Track things like if you're doing asynchronous tasks where you've got like 27 different functions that go in a row, and you want to know which one failed, you can use like module that tracks which ones have been executed and stores them in a memory object like this. The overhead of doing that is very low, but it means that when it comes time to debug a core dump, you can go and look in there and see where did it fail, and you can go and find all the objects that it was using, and the stack trace will include, you know, the arguments of the functions. So you can see in here the value is 14, which we also saw in that other object. You know, if you go and read the code, you can tell which file it was in and a bunch of other stuff. These are all the sorts of tools that, like, when you're running like a web application across like 27 different nodes, like it can be really, really good to be able to do this kind of debugging after the fact, rather than trying to do it on the production system while it's behaving poorly and in ways that will tend to break it. So, a little bit about the implementation of networking. This is cool. So, when you run a job in the Manta system, it runs in a private NATed network that doesn't have an internet address. So, in order to get a session, like an interactive session, total session, I had to create a reflector service. So the mlogin spins up a Manta job, which then runs, you know, this is the user client part, creates a Manta job, and then connects through WebSockets, like upgrades to WebSockets through HTTPS, so it's all encrypted, through the front door web server, which we call Muskie in Manta, and then to the reflector service, which is listening on WebSockets again through, so there's authentication happens in here and a bunch of other stuff. The reflector, and then eventually the Mala job a few seconds later will be scheduled, which is like the Manta compute job part. There's an agent that also then connects back out through the front door to the reflector, and then based on the job identifier, they get married up. And so there's essentially this WebSockets connection, which is reflected back through the system. So when you do an mlogin session, rather worryingly, it goes through about 5 or 6 different machines to get to you. But this seems to work pretty well. And I think this is, like, at least in part, in testament to the really low latency sort of Node's really good for low latency network applications. You know, just the ferrying of data backwards and forwards is really the best thing it can be used for. So a lot of Manta is ferrying data backwards and forwards. So, you know, Node is particularly well suited to that. And particularly this mlogin example. You can see the client portion of mlogin is open source. It's in the Node Manta toolkit right now. And the WebSockets library that we wrote to make that happen on the command line rather than in a browser was in there as well. And one of the things that we added to the, it's called Watershed, but it's an NPM module. It has dtrace probes in it as well. One of the things that those of you who've used WebSockets before will know is that it's a framed protocol. So you dispatch messages essentially to and from the client and the server in frames. They have a type. They have a some contents. So I have dtrace probes in Watershed, which were very helpful when debugging the protocol interaction between the client and the server, because it sort of goes past without you being able to see it. Particularly, it's in HTTPS, so it's very hard to sort of fish that out as it goes past, like with TCP dump or whatever. So these dtrace probes allow you to fish out just the contents of each WebSocket frame as it's sent and received, and marry it up with the connection. And so you can do debugging and you can see what messages are being sent and received by. You know, if you have 8 different processes on the server that are all doing this stuff, you can aggregate the results of all of those together. Dtrace has a lot of aggregation features in the kernel. It's very, you know, it pulls information up out of the process into the kernel, packs it all together, and then gives it to you for display, essentially, which is about as efficient as we can possibly make that. So that's mlogin and Manta. So there are some trial cards here. We need a Joyent public cloud account to get Manta. These cards, like, have a URL and stuff on them if you want to take one. We also hang out in IRC. We have hash SmartOS, hash Joyent, and hash Manta on Freenode. And we also have a few different mailing lists and a bunch of websites. We try to be pretty responsive to people as much as possible, because it's good to get community feedback from people that are actually using Node. Truly tremendous uptake of Node in the last few years. It's really makes us proud, but also sort of validates, we hope, the decisions we undertake to build these tools and to try and sort of make it easier to fix the problems that people will have in production as they stand up these systems. So I guess that's probably it for me. Are there questions?
Yeah, jump on here. Yeah, so you mentioned tools like, I guess, MDB,
Yeah.
the dtrace at the beginning that are available on SmartOS.
Mm-hmm.
You mentioned maybe porting them to other OSs as well. Is that
So there's some nascent ports of dtrace to other platforms. Like for instance, you can run some amount of dtrace on your Mac right now. Like Apple did a port with that. Some of the stuff that I showed where you can get a JavaScript stack trace out and do the flame graphs, you can't do that on Mac because they didn't support that feature. So I mean, there are open like Apple radars to get that fixed. So if you have an Apple business representative or you talk to anyone at Apple, you should lean on them to get them to fix that. That'd be cool. There are also there's a dtrace port to FreeBSD, I think, and there are 2 ports to Linux, one by Oracle and one by some community dude, both of which are kind of not great at this point, as I understand it, because, I mean, dtrace took a long time to get right before it was released to the public, and then like when it was released to the public, it's now been out for like 10 years. So it's one of the primary tenets of dtrace is that it is absolutely safe to run on any production system at any time. You know, there's nothing you can do with it to break the system, which is very important to us because we let customers run it. So like on multi-tenant cloud systems, it's pretty important that that works really well. And you can do it without impacting your application as well as just other people. So like the Linux stuff is, presumably we'll get there eventually, but there are still a bunch of things that aren't in the port, like the Mac port doesn't have the stack helpers for Node. The Linux stuff, presumably, I don't think has that either at this point. But it has like some of the kernel level tracing. I think there are still some ways you can panic it, which is not good. But I mean, suck it and see. You know, I mean, we would like to see people getting out there and using this stuff. Obviously, we would love for you to use it on the Joyent public cloud. People often bring applications to run on the public cloud just to debug them, and then go back to doing whatever they're doing before. So we'd love for you to stay, but the tooling is that good that people have been doing that for a little bit. So and then some people get addicted and decide to move their production loads over, which is good.
There is also an operating system, SmartOS, in case you guys haven't heard of it. It's open source, download it, run it. I mean, MDB's on there as well.
Yep.
Dtrace and so forth.
Run it in VMware on your Mac, which is what I'm doing right now. All of these, like, this here is an instance running on my Mac, which I SSH'd into. It's just an instance of SmartOS. It's like a couple hundred meg, it's not big. And then that lets you play with all of the stuff that we use to bring you the same services into the cloud, sans the cloud provisioning bits, like that's sort of Joyent proprietary, but the actual operating system and dtrace and MDB and all that stuff is in this. And if you want to play with it, then that's a good way to get started, particularly in Australia, because we do appreciate that there's a bunch of latency between here and the US, for instance. So it's you want lower latency access to some of this stuff, then the VMware image on your laptop or booting it on a real server is probably a good way to get started locally. Yep.
SmartOS runs on x86?
It does.
Not in Spark.
Not on Spark.
No. Okay. All right.
No, Spark.
It's
Pretty much done.
Is it a port of an open Solaris?
Yeah. So the heritage. I mean, Sun open sourced Open Solaris in 2005, and then a bunch of stuff happened, and then Oracle happened, and we don't talk about that anymore. But
Okay.
Much sadness and wailing and gnashing of teeth. But now, in the open source future is the Illumos project, which is the core of what was Solaris, which is it's what used to be known as the OS and networking consolidation, which is like the kernel and the C library and dtrace and zones and ZFS and all the core technologies. And then SmartOS is a distribution essentially built around that, specifically targeted at cloud deployments. Because that's our bread and butter at Joyent. So SmartOS, and there are a number of other different distributions. Some like SmartOS is built to boot from either the network or a USB key, and have a bunch of like read-only state so that it can be really easy to upgrade. So you just swap out the USB key image and reboot, which sort of dodges around all the package management aspects that people have traditionally sort of, package management style upgrades tend to be the sorts of things that go wrong. So we try to remove as much of that as possible. But it's been good operationally as a decision to do that.
Is Smart OS open source and it runs on the?
It is. So there's a GitHub repository, SmartOS Live.
Run in VirtualBox.
Pardon? You can run it in VirtualBox. That's true.
VMware.
VMware and a bunch of other hypervisors, I would imagine.
Yeah.
I mean,
Alright.
anything that you can run Solaris 10 in, you can absolutely run SmartOS in. Like, I mean, it's it's that code. Like, plus a bunch of extra stuff. But I mean, you can download it and build it. It's self-hosting. Like, if you want to build a new recompile it, change it, modify it, it's all there. So it is completely open source.
Yeah, pretty good.
Yeah. We have a lot of fun writing it. So. Questions? No?
I got one.
All right.
You mentioned, so I haven't played much with the Joyent public cloud, but we do most of our production hosting as much as the latency stuff. We use Heroku. It just makes deploying and sort of monitoring and scaling so easy.
Yep.
I was just wondering, I mean, could you give a brief overview of what the Joyent public cloud is like to use?
Okay, so the Joyent public cloud is first and foremost an infrastructure as a service public cloud. So what you get is like hopefully a SmartOS instance that you run your Node application or some database or whatever in. But at that point you are essentially getting machine instances to run Unix software in them, right? So you do all the sysadmin tasks that you would normally expect from that. We have a number of there are a number of PaaSes that sort of exist and run their stuff on us. So like Node.js, for instance, are a big partner of ours. They have a Node platform as a service, and they're a big customer.
I take it back then, I have played with Node.js.
You haven't?
I have.
You have?
Yeah, so.
Yeah, fine. So they do a lot of, like, they run a lot of applications on us. But I mean, it depends on how you want to run your application. Like if you're keen to like look after how all the decisions are made and do infrastructure stuff, which like once you get to be a big customer, sort of like Voxer is one of our big customers. They do like a push to talk application, like a mobile TCP VoIP style type thing. They have a lot of instances and they use a lot of Node for like front ends and moving the audio data around. And they do all their own sysadmin stuff. Like they're not using any platform as a service stuff. They're really keen to optimize it as much as possible. So that's sort of infrastructure is the level that they get in on. We try to make it reasonably easy to get in and get started. Like there are a lot of packages, like binary packages for common bits of software. We've done a lot of porting work to get things to work reasonably quickly, like one-line install type stuff that you would get from Ubuntu or whatever. You can also run Ubuntu, like we do KVM virtual machine stuff as well. So we have various Linux distributions and even Windows, if that's your thing. Though I mean, obviously, we would encourage people in order to get the best performance out of this stuff. Like SmartOS is the way to go. And certainly to get all the debugging tools and the monitoring and instrumentation stuff like dtrace, MDB, that stuff's on SmartOS. So that's that's what we use to develop all of the distributed software that runs this stuff. And so we have a lot of experience making that go really well.
In terms of getting access to some of these tools on PaaS service, like, so if we were to do hosting on Node.js, for example, how much of that is still available? How much, like, how close to the infrastructure do you have to go to play with those things in production?
So I'm not 100% sure what Node.js are doing around dtrace. I think that they have some dtrace support. Like, certainly I think internally they use dtrace to measure performance and stuff like that. If you can get a core file out of them, like if you can, so like Node has in the process module, they have an abort routine. So if you call process.abort, you will generate a core file. The process will stop and you'll get a core file. I'm not 100% sure how you would then fish that out of Node.js. I think that you can just get files out that are created in the instance. So like, I mean, that would be one way to do that. And then if you can fish the call file out, then you can run it, you know, you can upload it to Manta or something, and then just plug in, run MDB for as long as you need to, and then spin that down. So that would be one way to do that. You could probably actually automate that as well. Like you could, assuming you get access to the file system in a Node.js instance, like if you generate a call file and you have call files lying around, you can have the software uploaded to Manta in the background, and then like you'll have a list of call files that you need to go and look at later. Which is basically what we do with the JVC with the system that Brian wrote called THOF, which sits on all the compute nodes in the whole cloud, you know, thousands of machines, and every time there's a core or a crash dump, it uploads it into Manta, and it's, you know, so there's like, we have about 300 of these things up there now, and then we go and attach tickets in our ticketing system to it. So the workflow that we're building around that is being able to all collaboratively debug these things without having to fling call files around all over the internet. And yeah, so you could do something pretty similar, I would imagine, with Node.js. Obviously, I don't have the pre-canned code to do that, but patch is welcome, I guess.
Yeah.
Smart OS can run other applications aside from Node?
Absolutely. I mean, it's, you know, anything that you can build on obviously a Solaris-like system or a FreeBSD-like system or a Linux-like system, generally you have to work on Smart OS. I mean, and like we have thousands of packages pre-built already, so if you want Nginx or Postgres or MySQL or MongoDB or like any one of thousands of other pieces of software, you know, we have an FFmpeg package for transcode, stuff like that. We have all different kinds of bits of software. It's reasonably easy, particularly these days. We've done a lot of work to make building software that was probably primarily developed on Linux much easier to build. You know, so a lot of things we'll just configure, make install with the packages. So, and I mean, we're always interested in hearing about stuff that people want that's not in a package already, so that we can make more packages for like customers.
Like, could you run a Hadoop cluster?
Yeah, I mean, we have some offerings, I think, with other companies that do. I'm looking at you.
Don't look at me. I know that we have a Hadoop in there somewhere, but like
There are a couple of
the
different
people who are using it aren't like we're not asking questions.
Yeah, I mean, you know, again, it's infrastructure, so like you can buy as many machines as you want, instances you want, and run it up. I mean, we would encourage you probably to try one, like manage off as much as possible, because I think that's a better economic model than like Hadoop clusters require a whole bunch of systems administration, and then like all of the jobs that you write have to be really custom Java code or Hive or whatever the code at the moment. Whereas like, I mean, the simplicity and elegance of the Manta model is more that you can just write software that would have run on your laptop or on a Linux machine or a BSD machine. Like it's just Unix software. Everyone, it's the lowest common denominator stuff. So like you've got a Python script or a Perl script or an auth script, some C code, or like some people doing statistical analysis with R as well, with a bunch of R packages. So like you can get R to run on Manta if you've got like a lot of log files and you want to do some kind of breakdown plot of latency distributions or something. You can do that with R pretty easily. I think syntax is a bit weird for me, but what you're telling me is pretty great. So you know, we have a lot of different software available, and we're bringing more stuff online